Can everybody hear me okay now? Sounds good, yeah. All right, so I'm Manuel Paul with Deutsche Telekom, and I have the pleasure to start this afternoon session here. And well, it looks like we've got 5G, and we're past the hype, so we need more seats actually. So it's a very packed room. That's very nice to see. So my presentation is going to be about use cases and opportunities with MCORD, and the agenda that I've prepared for today, and that should actually not exclude a bit of discussion and Q&A at the end. But I would like to start with an overview about MCORD. So what is MCORD, and why is it relevant to operators like Deutsche Telekom? Then discuss the lightweight EPC use case presented to you, and make sure you got the idea of why we actually think that this is really, first of all, ready to hit the market, and is also very, very relevant with regards to the enabling work that MCORD provides for us in that regard. Then I've got the third item on the user plane. So I'm going to talk about a bit why optimizing the user plane is a key concern for us, and again, what does MCORD and the community work offer in that regard. And yeah, then last but not least, after having talked about challenges and enablers, I'm going to sum up and discuss potential next steps that we of course would like to do in collaboration with the community. So let me just start with, as said, the quick introduction of MCORD. So what is MCORD? It's a solution for mobile and wireless. So it's based on CORD, so open source, an open source platform. And it is actually, right now, as we've introduced reference designs, right, that give a guidance and provide sort of an assembly or a cookbook to put together a complete solution that satisfies carrier use cases. So MCORD right now is an exemplar, meaning it's an open source implementation. And in that regard, it does enable a number of use cases, but we are just about to take them into a prioritization and then, of course, evolve and advance use cases based on that towards production. So with regards to what is currently addressed by the platform, there's basically three areas, and I believe there will be more talks this afternoon that will detail and go into one or even several of these in greater detail. So the first area, and that's also the one where I'm going to focus on a bit, is the disaggregated EPC, the packet core with a cloud-native scale-out design that is pretty mature in MCORD in the exemplar right now. Second is the disaggregated radio access network, another key area that is built through the principles of SDN and open source, and provided in MCORD in a prototype implementation right now. And certainly then we've got a bit of an additional new topic here, new in terms of there's certainly a bit of hype around that, but it's an area that we are also getting ready to tackle, multi-access edge and services that allow to address the different needs around both mobile but also converged systems, and so in that way allow differentiation with QoE and application-aware networking. Oh, I see. Okay, all right. So it's pretty much that I need to stand a bit here and okay, run it from here. No problem about that. So let me then start with the just brief look at the opportunities that operators have here, and obviously, if you're interested in 5G, you are also interested in what has been already done on enabling 4G. And so for us as Deutsche Telekom, we are very interested in using a solution that allows better resource utilization. So I think this morning we have heard the keynotes talks about the challenges that operators face with regards to growing bandwidth, and so capacity demands are going up, and with ARPUs that are stable or flat, there's need to drive a lot of efficiency into how to handle packet transport, and in basic approach here that is possible through the means of leveraging commodity and open hardware, right, and open source software. So that's one of the key aspects, addressing cost per bit. But another area is diversity of use cases. So now it's not just mobile broadband, and new services are just hitting the platforms and need to be provided. And so this is another aspect and another area where operators are very keen to leverage this solution and this platform. So having talked about new use cases, I think we all agree that without proper automation, a number of the complex new services cannot be done, and at least cannot be done efficiently in terms of the operations. So that is another aspect addressed by MCORD, and maybe it's not detailed here in this high-level overview, but you see a lot of course, enablers through CORD itself, meaning there's deployment as well as operational aspects. And so this is a point about platform and service automation. So if you look at what is available, right, and then consider what is in front of us. So MCORD right now already covers a multitude of use cases in radio access network, edge, and set core. And it's based on the principle of disaggregation, virtualization, but virtualization has different means to different people, and I'm going to talk about it a bit more in detail with regards to, sorry, I should have swapped the slide also, of course, then it makes more sense. I would speak more about it just as we go. What is key here is that the principles, how the functions are realized, as said, follow a design of cloud native and virtualized and automated deployment. So looking at the radio access network, SDNization is a keyword here. And when we look at the core, and that's where I'm going to focus on a bit in this presentation, is SDNization of the user plane, or for the user plane, allowing an offload of the VNF, and in that case, the functions relevant to user plane handling, so that the underlying platform and the, in that case, switching hardware, the forwarding hardware, can take over some of these functions, which then allows us to drive the use cases mentioned below here in a very efficient way. So 3 areas as said, and those areas are right now being looked at, being discussed, and there's interest forming around this just in a general way of saying where there's the opportunity for converged packet core, disaggregated access, and edge cloud. So just to give a bit more color to what is already available, and so also using this as the, well, let's say that makes us headway into how quickly can we innovate using MCORD as a platform. And so from your perspective, right-hand side, there's a high-level intro figure for a multi-access CORD prototype. So multi-access CORD is a bit different to multi-access edge. It's a demo, a prototype demonstration that we have put together very quickly, working together with Radisys, an integrator, last year, and demoed this at MWC 16. I think it was MWCA to be correct, last year, which actually showed that it was very easy and straightforward to do a prototype implementation on MCORD, allowing a dual home CPE with actually a bandwidth boost to be done, to be implemented. Of course, as I'm going through and going to be focusing on not just the prototyping aspect, but what is now in focus at the operators and at Deutsche Telekom for productization. We do need more than just a rapid innovation or a platform that allows to do that. And so that brings me to the actual use case that we are focusing on, and that is the lightweight EPC use case. So looking at what the platform provides, and that is a bit of looking at the exemplar, which is the MCORD code base that provides both the SP gateway as well as all the other functions relevant to enable a packet core, an EPC. There's a good chance and a really big potential to build on that. And if we look at what is possible, what is available to be done, we of course need to understand when we take this to production that we need all of the preconditions, right? So it's not just about functionality, but it's about a hardened solution that has a commercial support around. However, when it comes to what is possible to be done today, we think that with a small start approach, so that means a use case that is focused on fixed mobile substitution with a limited 3GPP gateway implementation and a distributed architecture. So with such a minimum viable product approach, we are very, very close, and the MCORD exemplar is very close to allow us to take that towards production. And so for the considerations here, just to detail out the use case a bit more, and as said, lightweight doesn't mean that there's not an absolute seriousness in terms of the stability and all of the operational requirements in a carrier network, of course, that need to be fulfilled. But technically, if you look at scale, right, and if you look at performance, what is a driver right now is actually bandwidth and efficient handling of the user plane and actual support of a high demand of bandwidth, maybe a less session scale at this point. And that is the perfect basis, as we believe, to go forward. So we do actually need to drive, let's say, the scale up to the upper limit here, but rather need to focus on just a 3GPP compliant implementation of necessary interfaces, including access control and, of course, also GTP tunneling and policy control. However, the real need and the demand with this use case is to provide for the features that allow to have high bandwidth covered for customers at 2 levels. Building, of course, lawful intercept and support of multi-generations up to 4G at this point. And having considered these requirements and then looking at what is available, so we see that there's already a good level of, let's say there's already a lot of enablement through the platform. And first of all, there's an interest in collaboration group around MCORD, so that is not just today, but it exists for, I think, about 2.5 or even 3 years right now. So there is a comprehensive exemplar platform, and that is thanks to Intel and Sprint's contributions, mainly to here the next generation infrastructure core and the CAPS-enabled control plane. And there's also a way of deploying that scalably with DPDK and data plane acceleration. Right now, if we look at what we would aim for with our use case and what we actually would think would make sense in order to deploy this use case, we of course look at, first of all, a sustainable community led by operators. So I think that's where the focus with the ONF TLT and the structuring into reference designs comes into play. So we are close to getting that done Then looking at the platform itself, the code base that then should drive this and support this would be a near production grade code base. And I think it's not on me to do this announcement, but I think there's pretty soon an improved version of the code that is going to be released to open source. And that would be build a perfect basis. And one of the other items, so user plane optimization, is something that I'm going to talk about a bit more in detail. So just in conclusion, we can say we've got a lot of these enablers, and we've got a lot of proof points already for MCORD, and particularly the diversity of use cases that it can provide. And if we now think about what and how we take into production, we see that through the focus on certain use cases and the establishment of reference designs at ONF here, to strengthen the community collaboration, give guidance to the further advancement of the already near production grade code base, right? We are pretty much ready to take this to deployment. And so with regards to getting it to deployment and focusing on the efficiency that I've highlighted a number of times already. So let me just consider also not just that there is great work in progress on MCORD, right, and the functionality is set, but there's CORD as a platform, and the evolution of it through other reference designs as they were introduced by Guru this morning. So there is a lot of enabling work on the way of how you can actually deploy and leverage the infrastructure underneath. And so just looking at this leaf spine fabric, which is displayed on the right-hand side here in the figure, there's an absolute opportunity to consider now with a CUPS, right, control user plane separated way of deploying such a mobile architecture, to consider how to offload the user plane to the available hardware in the fabric. And so that is a key consideration for us, and the approach that we see, and I think that is something where we of course are interested in collaboration, as I'm going to highlight as we go. But right now we think that from the perspective of what is already done and what can be done, SP Gateway is already was already demonstrated and has been showcased at the MWC 18 by the ONF team. So great work done here by the ONF team on a P4-enabled VNF offload for the SP Gateway. So next item that is already being addressed and being worked on, also with the use cases highlighted this morning, ZIBA and UPAN. That is the BNG deployment, or deployment of a BNG user plane offload embedded on a fabric switch. And I mean, it's at this point just a matter of combining those, and P4 enables certainly that with the aspect of programmability, right, to use several programs on that same hardware to do a side-by-side deployment and actually convergence of these use cases on a common platform. So this is great enabling work, and now probably I don't know how many people are familiar with SwitchBP, so I don't want to bother you too much with standards and specifications around. Just a maybe quick check, or who's familiar with SwitchBP architectures, 5G architecture, system architecture? Well, that seems to be a number of people, so maybe then just let me cut to the chase here with control user plane separation, a concept that is very SDN native, right, has been brought into the SwitchBP specified system architecture for, the mobile system. And that has been a foundation also for the 5G work that is moving ahead, and release 15 is already done. And that is an inherent concept. So looking at what we can do next, right? And so looking at, considering at the basic concept that is built into the 3GPP releases since release 14, we've got the option and the chance here to actually consider whether we also can do this using the MCORD user plane offload. And our question that we took into an analysis internally at DT was, what is the status right now? And can we do this with P4? So a programmable approach today. So what we considered was just looking at the, let's say, typical scenarios and requirements in a carrier network, right? Can we do this in terms of the number of flows? So there's typically a number of around millions of flows that a mobile packet core needs to support. There's a high creation rate, meaning attach, detach handling for UEs. And there's quite a complexity on dynamic QoS. So looking at 5G, right, we might come to even the consideration there's work that enables to be more selective in terms of what you really need to enable, what you really need to implement, and what you really need to instantiate for a certain service or use case. So I think slicing is something that a term that we already came across a number of times here. But even without mentioning that, we're taking it a little bit more into the scale with regards to both hardware and control plane here. And looking at the status quo, we came to the conclusion that it's pretty challenging right now to support a full-blown EPC, at least in the way of deploying it centrally or centralized as done today using P4. So the number of challenges hit. However, question would be, with the use case that I've just introduced and that is pretty key to us, do we actually hit those challenges? And so our approach here, and that is, I think, where we also, as I said, discussed, start out small, right, would be focusing on fixed mobile substitution or fixed wireless access and hybrid use cases. We may have a pretty decent starting point, a pretty viable starting point to look at the optimized user plane handling using a programmable hardware approach. And so just to take this a bit forward, right, we considered what to do next, since, of course, this is something that, again, is perfect to be done with a community around MCORD, and looking at a POC, a proof of concepting opportunity around the use cases, right? But considering here the start simple, start small approach. So we were just thinking that from the perspective of a reduced set of requirements, enough to drive the fixed mobile substitution use case, you might have a good starting point to do basic functionality and performance issue testing and analysis. So a number of questions that would be certainly relevant around performance, how much sub-functionality would be needed for the CAPS interfaces. And actually I didn't spend too much time on introducing them, as said, right? So CAPS interfaces actually mean the interface between control and user plane. So looking at the breakdown of what is really needed for QoS and where and how to implement the control plane. So those would be the questions, and something that I would just like to raise and ask the room and the larger community whether there's interest in working on such a proof of concept. So, I mean, we don't need to discuss it right now, but if you are interested, just feel free to see me afterwards. I will be around, and certainly also be happy to discuss this opportunity further. So then looking a bit forward right here and right now, 5G is on the agenda, right? 5G is also part of this session's title, and so if we look ahead and having briefly introduced the CUPS as a key concept, but there are other concepts that were taken forward and developed into the 5G system architecture, and one that is pretty relevant and innovative both, but also very relevant to the deployment as a service-based cloud-native architecture that 3GPP has adopted. There's work ongoing in the standards bodies on fixed mobile convergence, cooperation between 3GPP and Broadband Forum, just on these functions that I've briefly addressed and are shown here on the chart. So there's definitely the opportunity once there's programmable hardware or hardware in place, merchant silicon, programmable or not programmable, but able to support these use cases mentioned, right, and the user plane offload for both the packet gateway or SP gateway as well as a BNG user plane. And then there's work in progress at ITF on enhanced user plane protocols. Again, another area where there's good work and good innovation in progress to further simplify the user plane and make it, let's say, use case selective or application aware. So having said that and looked at the enablers, let me sum up. And so when we look at where we are right now with MCORD, I hope you would agree with me now after having looked at the status and the great work that was already done by the ONF community and led by the capable hands of August here, the ONF MCORD chief architect. We see that there's 3 areas that were carved out as the key areas, right, where we can take MCORD and the exemplar platform, the open source reference implementation to the next level, driven by carrier use cases. So from DT's perspective, the first item on the list here is the lightweight packet core, which we see as a short-term need to take towards production, and also a low-hanging fruit in terms of what is available from the perspective of the exemplar platform in MCORD. So definitely, as talked about this morning, there is other ongoing work on other use cases, SDN-enabled broadband access that allow us to leverage synergies for convergence and for the actual combination with the work in progress. And looking at the radio access network just for a moment, there's definitely then a step that I think operators are keen to take to add in the ORAN compliant RAN components, which were already available through a prototype implementation for an XRAN compliant interface and API in MCORD and already demonstrated. So we are very keen to also take the concept of abstraction and disaggregation into the access network. So, and then last but not least, of course, the larger area of edge computing, which requires also not just to support control user plane, but rather a full dynamic service lifecycle. So there might be concerns and considerations relevant to multi-tenancy that need to be addressed. And of course, this can only be brought into production once it's fully automated. So for us, and I think for the larger community, the next steps would be to establish reference designs and collaborate on the use cases that drive the exemplar platform work. So I think operators are just in the process of working together and taking lead on structuring the new RDs, potential new RDs. So these would also then motivate, of course, further community collaboration and a specific focus on, as said, enabling these use cases and take them to production. So that would lead us to the stage where we are, I think, looking at the list, right, from short-term lightweight packet core up to edge computing, where we are able to leverage components from MCORD and build a scalable and near production-ready platform. So that is actually where we are at DT very interested in and looking forward to teaming up with the community. So that means it's both a call as well as, of course, our commitment to be ready to contribute and help drive this work. And as said, if you're interested in the prototyping activity, proof of concepting around P4, please do not hesitate to find me, see me, talk to me, and I'll be very happy to have your feedback. So with that, thank you very much. And I don't know if there's time for one question. So I think as we don't have a session chair, I don't know if I need to look at my own watch. And so at this point, we'll do that. So thanks very much. Okay, there's one question, yes?
Check, 1, 2.
And my question is that in your POC, the P4 switch you used are only functioning as user plane functionality, because you know P4 switch maybe has so many physical ports and none. I think I'm not sure, but maybe normal servers, non-EPC servers are connected to that switch. So I'm not sure, but the people using P4 switch only user plane functionality is kind of a resource. I mean, yeah.
So if I got the question right, you're asking whether it's possible to
yeah, P4 switch has so many ports, and maybe P4 switch can function normal L2, L3 functionality and plus user plane functionality. But my question is that in your POC, you use that P4 switch only for functioning user plane off-road?
So right now, I think there has been a demonstration by ONF leveraging existing fabric. So that's actually a scale-out architecture in terms of you have a more distributed way of getting these user plane functions deployed on an existing leaf spine fabric. So the idea is when you've got this fabric in place at an edge location that might be a central office or somewhere else, right, depending on your use case, then you actually would also scale and distribute those functions a bit further and not just do one centralized, let's say, deployment or operation of these functions. So that means, I think the scalability in terms of ports or connections was your concern. I think that can be addressed through this, but definitely, of course, there's the underlying hardware needs to support it. Yeah. Okay. Any more question, or otherwise, probably the next speaker is ready to. Yeah. Okay.